For all the problems in question number 18, we're going to be solving limits. And for some of these problems, for some of these limits, we're going to need to use L'Hopital's rule. And for some, we can't use L'Hopital's rule. So the first two here on the board above me, the first one is the limit as x goes to infinity, e to the x over x squared. So if you notice, this is an indeterminate limit as written because the bottom is infinity and the top is infinity. So if you have infinity over infinity, that's not a determined limit, that's indeterminate. So we need to solve it, and in this case we can use L'Hopital's rule. And in this, what we'll do when we show how to do this one with the L'Hopital's rule, we'll prove a result that you can use kind of just as memorization later, which is an exponential function always is bigger than any polynomial. So in this case, if you know that fact, you can look at that and say the top is always bigger, therefore this is infinity. But let's show it by L'Hopital's rule. So L'Hopital's rule says this limit is equal to the limit of their derivatives. So the derivative of e to the x is e to the x, and the derivative of x squared is 2x. That's still indeterminate because the bottom and top are still both infinity. So we could do L'Hopital's rule again. So this limit is equal to the limit of their derivatives. This would be e to the x over 2. That limit now is not indeterminate. And the top is infinity and the bottom is a constant, so this limit is infinity. So again, this is a pretty common result that you can get used to. An exponential function is always bigger than any polynomial. And you can see why that is by doing L'Hopital's rule, because every time you take the derivative of an exponential, you leave it the same. But if you take the derivative of a polynomial, you always go down in power. So it might take you multiple steps, but you always get it. So for example, you could have this same function where it was limit as x goes to infinity, e to the x over x to the 100. For a thought experiment, let's do that. So this is one where you would need to recognize this pattern because you're not going to do L'Hopital's rule 100 times to solve this problem. But on the other hand, you can see, well, e to the x is an exponential. This is a polynomial. It's indeterminate right now, but the top is always bigger. So these limits are in fact the same. It's still infinity. The e to the x always wins. So whenever you are comparing a polynomial to an exponential, whether the exponential is in the numerator, denominator, or what, that one is going to dominate. So in this case, this would be the same limit, infinity. Letter B, we have limit as x goes to 0, x plus sine x over x plus cosine x. So we need to plug in 0 to figure out if this limit is indeterminate in the first place. Because remember, you can only use L'Hopital's rule if your limit is indeterminate. So if we plugged in 0, our numerator would be 0. Our denominator would be 0 plus cosine of 0. Cosine of 0 is 1. So we get 0 over 1, which is 0. So that's not indeterminate, and the limit answer is just 0. So remember that you can only use L'Hopital's rule if your limit is in fact determinate. So just because you're asked to do a limit problem, that doesn't mean immediately do L'Hopital's rule. Because sometimes it's easier. You just plug in the number and you figure out what it is. So remember, you can only use L'Hopital's rule on indeterminate limits.
The Teaching Center, UF's Learning Resource Center.